Welcome to another recording for Pharmaceutical Calculations as you prepare for your screening assessment. The foundation of many pharmaceutical calculations is based on basic mathematics, knowing your symbols and appreciating your operations. As you can see, multiplication, division, addition, subtraction is a big part of a lot of the calculations that you're doing. As such, laying out your calculation, laying out your work is very important. It is imperative that the foundation concepts are understood, as many times students may have the correct numbers but the incorrect layout, which is very crucial for your basic operations. Now, in your pharmaceutical calculation textbook, this is taken from the 12th edition, page 2 of the pharmaceutical practice. These are common symbols that you'll be seeing in your questions and that you'll be writing as well. Percentage, which means out of 100. Percent per mil, right? Or per thousand. Using your positive and negative sign. Subtracting. Plus or minus. The plus or minus symbol is normally used right here. The plus or minus symbol is normally used whenever you are writing error, your percentage error. Okay, that's normally used there. So for example, we say if you want a 5% error, then if the thing weighs 400 milligrams, let's see, 5 divided by 100 times 400 milligrams would be 20 milligrams. So you'd say the answer would be that number plus or minus 20 milligrams. So it tells the level of error that you appreciate. Division is also there. You're dividing as well. The lesser than, greater than, equal to, all of these signs, equivalent. The equivalent sign is normally used whenever you're rounding off. So for example, you say 4.9 mil, you have your equivalent sign to 5 to show that you're rounding off and equating it to something else. So please pay attention to these, right, as these are normally very important in your pharmacy routine mathematical calculations. This proportion symbol should be familiar right here, whereas the ratio is a colon, and 2 colon right beside each other makes a proportion symbol. So these are common symbols used in pharmacy. Basic calculations that you should appreciate. Let's move down to laying out your work. Now, when some students see this, they say, Miss, this is foundation, basic stuff. Yes, it is basic stuff that your calculator does for you. But you should be able, if your calculator is not functioning, basic mathematics you should be able to do, right? So it shows you how I was intentional in putting this here. So it shows you how to lay out your letters and numbers in any particular calculation that you're doing. Now, I found this to be a little bit interactive. Chalkboard calculator. When you put this into the website, which I did, I plugged in 8,350 divided by 25, and it was so amazing to see the real-time playing of the video. So this is a screenshot. This is a screenshot of the video that I got from the website. So, it was just so fun for those who don't remember how to lay out their work, right? The multiplication tool, there are websites here, mathmoji.com, that shows you how to lay out your work for persons who may be a little bit challenged. We will not require for you in PharmCal to do any long division or this long multiplication. No, you will use your calculator. However, we expect you to lay out the work properly. For example, in the video with ratio and proportion, setting up your common fractions, showing your cross multiplication, and deriving your answer. We're going to move quickly for the next 10 minutes. We're at 5 minutes in the recording into estimation. It is so important to be able to look at numbers and estimate your answer to know if under pressure and nerves you plug the wrong value into the calculator. So I introduced estimation in the recording that was done for ratio and proportion, specifically the question, I think, with the insulin dosing, where I think I recall, if I recall correctly, the factor was 2.5 when you were moving the dosage from 100 units per mil to 40 units, right? It is so important to know if you are getting the right answer, because sometimes you have long quantities of drugs. So for example, if this was an ointment and you use 7,428 kilograms and 3,652 kilograms, and all of these say they're the same unit, and you are supposed to add them to know how much kilograms of an ointment was used. Lay out your work properly, look at it, and you can estimate what your answer should be. So 7,428 is close to 7,400. And this is about rounding off. Estimation and rounding off is linked. So this would be to the nearest hundreds. 3,652 is 3,600. And we could argue and say 52 is 5. And so we'd round up to 3,700. But remember, this is estimation. This is not testing the skills of rounding off. So that's so important. 1,327 is 1,300. 4,605 is 4,600. 2,791 is 2,000. Here we have 700. And so I think because they're estimating the answer, they are not rounding up to see if they're going to get a great value. All right. You don't want to be estimating and get a greater than value. I think the idea is you get as close to the nearest answer. So in the principle of rounding off, this would have been 2,800. But I think I take note of your textbook, they had 2,700. 4,490, because it's just 10 away from 4,500. We put 4,500 here. So in your textbook, they estimate the answer to be 24,100. Let's just add again, 7,400 plus 3,600 plus 1,300 plus 4,600 plus 2,700 plus 4,500 is 24,100. So the actual answer is 24,293, right? Greater than the value we estimated because we round down. Let's see if we had rounded up, what would have happened. Let's go. So if we really follow the principles of rounding off, let me put it over this side so we can follow to see a comparison. 7,420 to the nearest 100 is correctly rounded off. 3,650 would have been, because 5 is here, so I'm covering rounding off in this, would have gone to 3,700. We would round up because the next number was 5, okay? 1,327 would stay at 1,300. 4,605 is 4,600. 2,790, right here is a 9, so we would round this to 8. That's the principle of rounding off. All right, I'm going to highlight that for you. And 4,005, because this is 9, right here is 9, and so we would round up. So let's re-add and see if rounding up would have landed us at a closer value to what the answer should have been. 7,400, and I'm doing this real time while doing the recording, right? 2,800 plus 4,500, and my answer is 2,400 if we round up. Okay, so we would have exceeded what the answer would have been. Okay, and so I think that is why your textbook had round down to the nearest 100 instead of rounding up. I could be correct in terms of guesstimating what your book was doing. Here they rounded the answers to the nearest thousand. So we know the answer would be near 24,000. And estimation is estimation. You're not getting the right answer. So these are the websites in the footnote where, and the books and the relevant pages for where the information was taken from. Let's look at the multiplication, right? Again, the mathmoji.com shows you nicely how to lay out your work. You're not going to do that in PharmCal class, no, but it's just for you to refresh your mind of what the process is. So let's look at this. 612 multiplied by 413. You should be able to estimate your answer. So if we take the 6, let me highlight the 6 and the 4, we know that 6 times 4 is 24. So we know that confidently the answer will be close to 240,000 because you're dealing with three zeros in terms of the thousands that you're dealing with. So again, you would convert 612 would become 600 times 400 rounded off to the nearest hundreds. And so, you know, this is 24 and 4 places of zeros. Your answer is 240,000. But the division is the same thing too. When you're dividing numbers, you round off to the nearest 100 or zeros, tens, hundreds, depending on what you're doing, so you can estimate your answer. And it is so important. We're finished with estimation, so this is the end of this recording. But why is it that estimation is captured in your foundation PharmCal textbook? Because oftentimes students plug in the values in the calculator under rush, angst, anxiety, under time constraints, and plug in the wrong thing, right? And so if you look at the numbers, they are patterns. The numbers speak for themselves. Round off to the nearest tens or hundreds or thousands and see what your answer should be, what it would look like. And this is a foolproof way of double checking and making sure that you are putting the right thing in. I remember doing computer science, and these are classic things for learning computer, garbage in, garbage out. If you plug in the wrong values, wrong decimal place, wrong number. I remember doing one of the recording and the number, I think it was 297 or 397. It was 975. Look back at the recording, right? And I had to re-record because it should have been 795 or 975. I put the wrong number in the wrong place. I remember also being in class when I was instructing one of the lessons sometime in the past, and I was thinking 26. I was supposed to write 26 and put 28 on the board. I have no idea where my brain came from with 28. And if you speak to students who have done pharmaceutical calculation, they will tell you these are the simple mistakes. They often say these are the stupid mistakes, miss, that I make that gives me zero. Yes, believe it or not, estimation is a big part of picking what your answer should be and keeping you in alignment to know if you put the wrong value in your calculator. So again, this is a part of the subtopic for this module. So we have covered Roman numeral. We have just done the operation, multiplication, division, your symbols, and estimating your answer. In the next recording, we are going to look at rounding off, significant figures, and standard form. Depending on the length of the video, I may split these into small videos. Thank you for your attention. You are now to go across to the 13th edition or the 12th edition of the PharmCal textbook and look at the sample tutorial questions. Answers are given, so it's just for you to practice independently and also along with your peers. Thank you for listening.